Okay, so we'll get down to the actual soldering itself now. So this is how I hold my soldering iron, and if you research this or whatever, you'll go on forums and they'll say stuff like, oh, hold it like this, hold it like that, oh, how can you do it properly like that? But I generally find that's a load of rubbish. Just hold it the way you feel most comfortable holding it, because if you've got small hands or whatever, and someone says, oh, you have to hold it like this or whatever, well, it's just not going to work. So hold it what's most comfortable for you. I mean, if it's not comfortable, you're going to struggle. So just hold it however you find to be most comfortable. And for me, I hold it like a pen, like that, and I find that's most comfortable. And because I'm comfortable, I'm more, I don't know, sort of agile, if you like. I just find it easier to manoeuvre around places, and I find that I can do a better job. So yeah, first thing is just be comfortable and hold it however you want to hold it. The next thing I'll mention is that when you're soldering, make the job easy for yourself. So if there's like plastic bits that come off here and they're kind of in the way, just take them off, because you need to make this easy for yourself. The other thing is that if you're working near plastic or anything that's basically not metal, even the PCB, be careful not to touch the PCB with the soldering iron, and don't touch the plastic with the soldering iron. And that's because when the tip gets dirty, it makes the rest of the job really hard, because when the tip's dirty and you're trying to solder something, then the bit that you're trying to solder gets dirty, and then you find that it won't connect properly, and you get a bad joint, and then you have to redo it, and then you have to use a solder sucker, and it's just a lot easier if you keep it clean in the first place. So if you're not sure that you're going to touch the plastic, then make sure you don't. Change your angle, take your time, or move this around, or whatever. So yeah, don't touch plastic. Don't get this dirty, because when the tip's dirty, it makes things so much harder. And if the tip does get dirty, don't carry on with the soldering. Take it away and clean the tip before you go back, because otherwise it's just too many. It'll cause too many problems. Something I usually do is you won't find this in books and stuff like that, and people will be like, oh, you can't do that. But what I usually do is just simply tap it on the side of the worktop. Just a few light taps, and what I find is that a lot of the junk falls off the tip, and I find that I can just give it a wipe, and it'll be nice and clean again. But you can also use other things, like some people have a brass scourer thing, and they just dip it in the brass scourer, and that cleans it too. But I don't do it that way. When it comes to soldering, I think it's really important to keep the workpiece very stable, and the reason being is that if you don't keep it stable, particularly when you're working with small components and stuff, you could be working with it, and the solder, when the solder gets molten or liquid, it kind of gets sticky, and it can stick to components, and then when you pull the soldering iron away, it can pull the component out of the way, or pull it out of its hole completely, or whatever. So keep it very stable. So whether that's using breadboard, or helping hands, or even blue tack or whatever, make sure you keep it stable. So when it comes to the use of heat, of course you've got a lot of heat at your disposal here, and you need to be careful that you don't burn anything. So what I've found is that it's better to underheat than overheat. See what happens if you underheat? You get like a frosty looking joint, and or sometimes a lumpy joint, and it doesn't look very good, and it isn't very good, and sometimes it can crack and whatever. So you do need to apply heat, but I think it's better to underheat than overheat. And the reason being, if you underheat a joint, you can just put the soldering iron back up to it and heat it again. So what I usually do is count to about 2 or 3. So 1, 2, 3, push a little bit of solder in, and then take it out, and it's done. But if it doesn't heat it in 3 seconds, then take the soldering iron off, put it on for 4 seconds. 1, 2, 3, 4. Put some in, and go like that. But don't do this. Don't just hold it for ages and then push soldering, because you could start burning it. And when you burn it, the plastic under there can start melting, and then the pins start to get deformed, and you can burn the solder mask, or you get burn flux, and it just makes a mess. So it makes a mess, and it doesn't look good, and also you can get dirt all over the tip, and then the dirt spreads, and then you can't get proper joints on these ones. So I think it's better to underdo it than overdo it. So just go easy, you know, 1, 2, 3, put some solder in, and that's it. And when it comes to the actual soldering, it does matter what it looks like, because generally the healthier looking joints are generally better. So the way this thing works is that you have a pad. So you have a pad and you push a pin through. You know, this is the standard way. You push a pin through. Let's say the pin's on a module or whatever. So there's the pad on the PCB. There's the pin sticking through, you know, 1, 2 and 3. So kind of like this. Kind of like these pins here sticking up. And the joint that you want to get ideally is something that looks like this, kind of like a volcano. So there's a curve across there, just like that, on both sides. Ideally that's what you want to try and get, but you can get a situation that's like this. You can get a situation where you have just a bit of solder there on one side, for example, and you can get a situation like this where it kind of balls up, or you know, it could go down there or whatever. So you get all these different situations, and that is actually okay, and that's okay, and that's okay. But then, if they're all okay, then what's the problem? Basically, the problem is that with this one, if there's any movement or anything like that, the connection can break. So if there's any slight movements, you could get a fracture in the joint here, and it breaks. So when we have, if we fill it up a little bit more to that volcano shape, that's a really good solid joint, and it's not really susceptible to cracking or breaking. So yeah, that's the problem with underdoing it. Of course this one's perfect, and over here still we've got a good connection. I mean, there's a lot of solder, there's no problem there. But the issue here is that if we say we have another connection over here, we've got another pin right next to it, then when you put the soldering iron over, and you put the soldering iron here, and you apply a bit of you know, solder or whatever, let's say you apply solder from here, what happens is that when it kind of balls up like this, but then when this bit joins here, and it joins to the next pin, the solder will sort of gloop together, and then what will happen is the solder from here will go over here and bridge these two together, because it kind of flows like that. So when you overdo it on one, and there's another one next to it, they can bridge together, and that's the problem with overdoing that. Well, that's the main problem anyway. So yeah, all three seam to contact, that's the best one. Just avoid these two at all costs. Okay, so it's time to turn the soldering iron on. So I'll just turn this on. I always struggle with this. There we go. So that's lit. I'll put it on low and just give that a minute to heat up. These gas soldering irons don't take very long to heat up at all. Okay, so these little through hole components here, so I've got a resistor and I've got a board here. So we'll put the resistor through this board. You can see here that the board is quite clean. It's not really clean, but it's quite clean. So I think I'll do it on the corner here. So I'll put some flux on there just to clean it up a bit more. Now I'm going to make sure that the leads of this little resistor are clean, and I believe they are. So now I'll bend the resistor to try and get this thing in place, just like that, and push it through the holes, like that. And I'm holding it on the other end, on the other side like that, and I'm just going to gently pull these leads apart like that. And what that will do is that will hold it in place. So I'll get my helping hands now, and let's just get this thing to hold onto it. What we want to do basically is heat up the pin and the lead at the same time. So I'll just knock off any excess solder I've got on there, Okay, so we want to heat them both up at the same time, put a little bit of solder on, and there we go. And the same for here, so heat them both up, 1, 2, 3, a little bit of solder, like that. There we go. Sometimes these things need a little bit of a touch up. Anyway, so there's the, oh, I can't zoom in that much. There's the solder joint. So if I just put this on its side now, you can see how it's looking. That's not a particularly beautiful job, but it's okay, it's good enough. So now if I just snip these off, there you go. I'll just hold it in here so that you can see. So that's through-hole soldering, and with through-hole soldering, what I usually do is solder the most difficult one first. So if you've got a lot of them, you could probably start from the centre, or just go for the most difficult one first. I find that's the easiest way. Okay, the next type of soldering I'll look at is this type. So commonly these are found on PCBs, and you have this this little set of pins, and yeah, let's solder this on. So to start with, the pins, as you're probably aware, go in there like that. They're actually dual-sided on this module, which is interesting, but I think probably you'd have it like that. So push them together, of course, and then this is where the breadboard comes in handy. So you've got the pins pushed in there, then push the whole thing into the PCB, and where's my blue tack? I'm just going to put a bit of blue tack underneath here to keep it straight. That should do, so it's stable and straight. Then turn it around, and turn it around just makes it a little bit easier. Then let's go. I'll just tap this to get rid of that solder. Okay, and zoom in. I would always start from this one here. Now I'm not exactly sure why I do that, I just find it easier. If you start from this one it would be difficult, so it's easier to sort of move like this, I find. Anyway, so let's start. These here are very clean, they're from the factory. I can see it's gold plated, so I feel as though I don't need to use flux. But anyway, let's heat them both up at the same time. Push a bit of solder on, and here you can use something called capillary action, and it's where you sort of allow the solder to soak into the hole, which is just below it. I've got a bit too much solder on the tip there. Some people also say that you should tin the tip, but I never do that. I don't think you need to, but anyway, that's just my opinion. So let's go again, and again. You sort of want to aim the solder in between the two, in between the pin and the pad. There we go, so I've done that. Just put my soldering iron to one side, and let's take a quick look. I don't know if this is going to, no, it looks like it's not going to zoom in. But you can you see the job there? It's quite a nice job. Quick and easy. Anyway, the next bit is this. If I just put this in here now, I assume that this will probably go here, like that. You probably don't actually need to use this, but I use it anyway. Now this one, of course, I can't push it into a PCB, so it's kind of like before. This one will just need blue tack. So I'll blue tack the piece together like this, and that's quite tough there, so it's blue tack together. Push it down so it's stable, kind of like that. So it's really quite stable now, so it's not going to move if I do anything with the soldering iron. Now these pins are a bit bigger, so I'm just going to put the power up just a touch to get this thing a little bit hotter. Tap the soldering iron again, make sure there's no bits on it, and let's go again. Now here I'd start with this one because this is the most difficult one. I don't actually know why it's most difficult, but I find that it's better to work in sort of a clockwise direction. Again, I think it's because when you're here you don't want to lean over and potentially touch that one. Anyway, so heat up the pin and the pad. This might need a few more seconds, and here we go, it's starting to melt. and then push some solder in. There we go. And on this one, 1, 2, 3, 4, 5, and let's push it in, and there we go. So turn my soldering iron back down and just knock some of the excess stuff off. Let's have a look at the job again. This kind of focus, yeah, there you go, that's quite a nice job. And there you go, and it didn't move or anything, and now I can just remove this blue tack, as we call it here, and you can see that it's a really good solid job. Look, it's flush to the PCB, it's soldered in well, it's perfect. So that's how to do these little modules. What's next? Okay, and now SMT stuff. SMT I find to be a lot harder. It's actually the hardest of all the different types to solder, I think. This is from an ESP8266 breakout board, it looks like. And on the back there's a space for an AMS1117, and of course that's SMT. So there's the board, and here's the SMT chip, which is an AMS1117 3.3 volt regulator. And we'll solder this onto here. First thing we need to do is get this thing to be very stable, because if it's not stable we're not going to be able to do it. And in this particular thing, because it's flat, I could use blue tack, or I could also use the helping hands. And I think I will use the blue tack. So yeah, first thing we need to do is get this thing stable. The thing with this blue tack is that you can't get it hot, because then it starts acting a bit funny. So let's just push some of this down here to get this thing held in place. Okay, so now we know that that thing can't move. Let's just zoom in a bit more. Is it going to focus? There we go. The next thing I want to do, actually it should be level as well. The next thing I want to do is put a little bit of flux on, because these things are clean, but I want to be sure, because SMT can be very difficult if it goes wrong, I've found anyway. So I'll put a bit of flux on there, just to make sure it's clean. Now I need my tweezers, and yeah, let's get started. Right, the first thing I'm going to do here is tilt this thing slightly, because this isn't a very easy angle for me to work with. That's much easier for me to work with. So the first thing I'll do is I'll just put this into place with some tweezers and make sure that it's going to align properly. That looks about right to me. I'll get my iron. Now what we need to do here really is to hold this thing down. So this is where it gets difficult. Now in this particular example, see, I don't usually do this, but in this particular example I am going to tin the end of the soldering iron just the first time. So I'll tin it, and we need to be quite quick with this as well. So I'll tin it, I'll hold it down with the tweezers, and I'll just quickly nudge some on there. Just like that. I'll let go, and you can see that it's done it. It's actually not a very nice job that, but it's done it. So give it a few seconds. 1, 2, 3, and let go. Right, now that's held in place now, so now the job is a hell of a lot easier, and now I don't need to hold it anymore, and yeah, I don't need to tip this anymore either. So I'm going to put it back to, whoop, I won't put it back to normal, I'll rotate it again. I'm just going to knock the iron and get any of this excess stuff off, and then let's carry on. So now with SMT you don't really need to use much solder at all, so I'll go for this one next. Put a bit on there, and that's done. And the next one, and we're done again. I think I'll just put a little bit more on this one. There we go, and I'll just touch up the others as well now. So touch that one up, that's done, that's done, that's done. There we go, and now the top one is the really easy one. I'll just rotate this again, and this is really easy. So I'll heat it up a little bit. I start from the end with these things and push that down, There we go, that should be it. And I'll turn my iron off, and that's it. Now you can see here the flux has got a little bit burnt, so you can actually clean this off with a sponge or whatever, but I'm not really going to do that. So let me just zoom in. No, that's as much as I can zoom in, but anyway, let's see if I can bring this closer then. Yeah, there you go. It isn't that pretty, but it's worked. So that's SMT. And sometimes it's not quite as easy, because sometimes I find that you have to solder diodes together, to boards. And with diodes you take the same thing, but it's just a little bit more tricky. Sometimes I find that you've got to hold a bit longer with the tweezers and whatever, but essentially that's how I solder SMT components. And the last thing is soldering wires together. We want to solder two wires together. So we've got the two wires. I've actually cut a little bit of heat shrink. Heat shrink shrinks by a third, or up to a third of its size, apparently anyway. Now this one is not a third, this one's too small, but it's okay because it'll work for this. It'll work no problems. So the first thing you want to do is push the heat shrink over the wire. And the next thing, of course, you just want to trim off some wire. I mean, for something like this I'd trim off probably about 7 or 8 millimeters. So I'll do that now. So next thing we want to do is keep this thing stable. So now if you can, it's a good idea if you can twist these together. So I get them like that, and then just twist and twist and twist a couple of times. Like that, and then pull them apart slightly. And you want to be able to get the knot bit flat, basically. Sometimes I use some of these just to flatten it off a little bit, but you don't really need to. Okay, other types of pliers are better for this, really. Right, so that's done. Then the next thing we want to do is put it in the helping hands. This is to keep it stable, of course, while we're soldering it. Okay. And we're ready, so I'll just get this in a better position for the camera. Right, so this is really easy. You just get the iron, get your solder, put the iron underneath the joint and hold it for a couple of seconds, and then just push the solder in. It's that simple. So there's the joint finished. I'll turn my soldering iron off. And right, so now it's still hot, remember, so take the clip off and then just push the heat shrink over it like that, and now it should melt on its own, but it looks like in this case it hasn't. So then just get some heat source like a hairdryer or your iron or whatever, and just put it underneath, and it should shrink. It should start to shrink. This is the beauty of having a gas powered iron. You can't really do this with electrical ones. Anyway, so that's that. And let's take a look at the end product. It's quite nice. Okay, and that's my guide. As a completely uneducated person in terms of electronics, that's my guide on how to solder. So I hope you enjoyed it, and thanks for watching. Bye!